Based on what we've seen so far, we'd like to draw this graph paper recursively. So we need a method that's going to do the job for us. It doesn't return anything. I'll call it GP for graph paper. And according to what we've seen, we need to take in at least three things. We have the lower x and lower y coordinate. Actually, it's lower left, so let me use two L's to signify that. And then we have some notion of the size. And it's worth documenting these parameters carefully because all the recursive calls to this method have to treat those parameters consistently. So this is going to process one layer of the graph paper, and this is the lower left-hand corner x-coordinate, and this is the lower left-hand corner y-coordinate. And size is the length and height of the current square. So what are we doing in the graph paper? Our primary step inside the graph paper is to draw two lines. So we want to draw one horizontal and one vertical line to quadrisect the square. That is, to divide the square into four pieces. We'll get to the recursion in a minute, but the primary task here is to draw these lines. I'm going to make the color red, just so we can see it a little more prominently. So let's set the pen color to be color.red, and we have to import that. And let's draw our two lines. So our lines go, horizontal line starts at x and goes y plus size over 2. That's the left-hand side of the horizontal line. And the right-hand side is going to be x plus size, and the y-coordinate is also y plus size over 2. So this is the horizontal line. And the vertical line goes from x plus size over 2y to x plus size over 2 y plus size. Now if we kick off this recursion, okay, so these x's I've tell you what, let me go ahead and rename this. No, I'll go ahead and make this LLX, and this should be LLY, just indicating that it is the lower left-hand corner. That's especially important because Sedgwick's API would normally take x and y to be the center of something, and we're using a different representation here. Okay, now we kick off the recursion. If we run this program, we're not going to see anything because the main program doesn't do anything. So what we need to do is to kick off this recursion, and we're going to call our method GP, passing it the lower left-hand corner, which is 0, 0, and the size, which is 1. Okay, so let's run this, and we should see something. Okay, so what we see are the two lines that we drew, the horizontal and the vertical line, and these conceptually divide our graph paper into four pieces, and more importantly for the recursion, they create four subcases, which we're going to need to address next. What remains are the four subcases. So let's think about the lower left subquadrant, and that's going to be at xy, at the lower left-hand corner x and y, but its size is now half the original size. Let me run this again to show that. So the lower left hand, this is xy, lower left x, lower left y, and size was 1, both horizontal and vertical. And this lower left quadrant is also anchored in its lower left-hand corner at lower left x, lower left y, but its size is half of the original size. So to specify that recursively, I can call GP recursively with the same x and same y, but this time I'm going to pass size divided by 2. Now let's go ahead and run this, but this is going to seemingly go on forever because we haven't put in a base case yet. Okay, so it worked here, and then subquadrant, 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 and it's getting much too small down there at the bottom. So what are we going to do about that? We need to put in a base case, which is simply going to be if our size is too small, say if it's less than 0.01, then we're going to return, which causes the rest of the code to be skipped, and that's the end of the recursion for that particular quadrant. So let's try this. Okay, so it's getting small, but I think this is actually too small. I'm going to make the size 0.05 so that it looks more like graph paper. We can actually see some separation between the lines. Okay, and that looks pretty good. So we subdivide, 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 and so on. And then in this quadrant, the size, which would be this divided by 2, the resulting size here is less than 0.05, so the recursion is abandoned. So we've handled one quadrant, but we have 3 more to go. So let's just go clockwise around. What about the upper left? Let me put these comments after here. So this is lower left. To get the upper left quadrant, what is its lower left-hand corner? It's the same x-coordinate that we were passed in, but its y-coordinate is whatever the y is plus size divided by 2. And then it gets size divided by 2 as its size for what it's supposed to process. Okay, so if this is correct, this is lower left x, we should start to see 2 different quadrants filling in each recursive call, both lower left and upper left. And so within the upper left, every lower left and upper left is being filled in, and that's where we get the pattern we see here. Let's add another one. How about the upper right? So the upper right is centered at the center of the bigger square. So that's going to be at LLx plus size divided by 2 and LLy plus size divided by 2, and its size is also size divided by 2, and this is the upper right. Just trying to make the code look a little better there, and let's try this. And 3/4 of our graph paper should be complete now. Okay, it's looking pretty good. So within each quadrant, 3 out of 4 of the quadrants are complete. With the big one, the right one is missing. With the small one, the right one is missing. With each of these, the right subquadrant, the bottom right, is going to be missing. So that's the one we need to do last. And the bottom right occurs at LLx plus size divided by 2, and the same y-coordinate is passed in, and its size is also size divided by 2. So with this in place, we should now actually begin to see the whole graph paper. There we go. Now the lines look as if they were drawn from top to bottom and side to side. Let's put in a little bit of a pause here so we can see it go a little more slowly. Let's suppose after drawing the lines we pause for half a second. So we see the clockwise filling in recursively of the regions. Up, right, bottom, and then here, bottom, then upper left, then upper right, and bottom right. And within each recursion, it's exactly the same pattern. Recursion has that property that everything is consistent in terms of the way it ends up behaving. And so we can see that these lines are being connected because they happen to be adjacent to each other, but they're not drawn at all completely from left to right or top to bottom. Instead, they're installed into these little quadrants that we see being drawn here. That's going to take a while, so let's go ahead and run this at full speed. There we go. And if I wanted to see the whole thing without anything in between, I could say show, and show again at the end. And this puts Sedgwick's graphics code into double buffering mode, and so this is going to basically don't show anything until now. So we'll just see all the graph paper appear at once like that. Let me show you that again. There we go. So we turn off the display with this don't show anything, and while the graph paper is being drawn in memory but not on the screen, it's being prepared so that we can see it eventually, and standard draw.show will then cause it to be seen on the screen.